Assalamu alaikum dear students, and today we are going to discuss a few more questions of this exercise. Now question number 15 from this exercise is the perpendicular from origin to the line y equals to mx plus c meets it at point minus 1 2. Find the value of m and c. This means that we draw a perpendicular from origin, that this is a origin because its coordinates are 0 0. From this we draw a perpendicular on a line y equals to mx plus c such that foot of this perpendicular is minus 1 2. This means that minus 1 2 lies on this line. Here slope of this perpendicular with endpoint 0 0 and minus 1 2 is simply minus 2 because difference of y coordinates upon difference of x coordinates. Also the slope of this line is m because it is in slope intercept form. These two lines are perpendicular, that is this perpendicular and this y equals to mx plus c, they are perpendicular, which implies that by condition of perpendicularity the product of their slopes is minus 1, that is m into minus 2 equals to minus 1, which implies that m equals to 1 upon 2. This means that slope of this line y equals to mx plus c is 1 upon 2, that is m is 1 upon 2. Also this point minus 1 2 lies on this y equals to mx plus c, which implies that it satisfies. So substituting the value of x equals to minus 1, y equals to 2 in this, we simply get c equals to 5 upon 2. Hence m equals to 1 upon 2, c equals to 5 upon 2 are the required values of m and c. Now if p and q are the lengths of perpendicular from origin to line this and this respectively, prove that p square plus 4q square equals to k square. Here p is the length of perpendicular from origin to line first, that is x cos theta minus y sin theta equals to k cos 2 theta, and q is the length of perpendicular from origin to second line, that is this x sec theta plus y cosec theta equals to k. Since we know that if the point with coordinates x1 y1, then its distance from a line with equation ax plus by plus c equals to 0 is d, which is given by modulus of substituting the value of x1 and y1 in given equation, that is ax1 plus by1 plus c upon square root of sum of squares of the coefficients of x and y, that is a square plus b square. Here the point is 0 0, and on line first x cos theta minus y sin theta minus k cos 2 theta, by transferring to this LHS, its perpendicular length is p, which implies that p equals to, substituting the value of x equals to 0, y equals to 0 in this, we simply get k modulus of cos 2 theta. Similarly q on second equation using this distance formula, we get k upon root of sec square theta plus cosec square theta. Now we have to prove that this p square plus 4q square, or we have to calculate the value of p square plus 4q square. Now when we substituting p and q in this equation, it is k square cos square 2 theta 4k square, because modulus mod of cos is cos square upon sec square theta plus cosec square theta. Now after simplifying these two in this expression, we simply get k square, because k square cos square 2 theta plus sin square 2 theta, which is 1, hence k square theta k square, which implies that p square plus 4q square equals to k square. Hence in this way we proved this by using the distance formula concept. Now question number 17. Now if we have a triangle with vertices a 2 3, b of 4 minus 1 and c of 1 2, find the equation of altitude from vertex A and its length. Altitude simply means a perpendicular, but from here we have to draw this perpendicular from this vertex A. This means that we draw a perpendicular from A to the side BC. This means that it is altitude from vertex A. Now here slope of BC equals to, by difference of x coordinate y coordinates upon difference of x coordinate, that is minus 1, which implies that slope of altitude by using the perpendicular this condition of perpendicularity, it is minus 1 upon the slope of BC, that is 1, which implies that slope of this altitude is 1. Hence its equation is here. This perpendicular one point is 2 3. This means that it passes through 2 3. It is slope is 1. So using the slope point form, we simply get x minus y plus 1 equals to 0 is the equation of this altitude. Now we firstly find this equation of BC, that is with point is 4 minus 1 and C of 1 2, using 2-point form of this equation of line, that is y minus y1 equals to y2 minus y1 upon x2 minus x1 into x minus x1. After substituting the value, we simply get x plus y minus 3 equals to 0. This means that x plus y minus 3 is the equation of BC. Now we have to find the length of altitude. This length of altitude is actually the perpendicular distance of point A with coordinates 2 3 to the line x plus y minus 3 equals to 0. So using the distance formula, we simply get modulus of 2 plus 3 minus 3 upon root of 1 square plus 1 square, which is simply root 2 units. Hence the length of altitude from A to the side BC is root 2 units, while as its equation is x minus 1 plus x minus y plus 1 equals to 0. Now if P is the length of perpendicular on the line whose intercepts on x and y axes are A and B, prove that 1 upon P square equals to 1 upon A square plus 1 upon B square. We know that the intercept form of line with intercept A on x axis, B on y axis is x upon A plus y upon B equals to 1. Now converting this or changing this into the general form of this equation, we simply get by cross multiplication bx plus ay equals to ab, and in second step we get minus ab equals to 0. Now it is given that the length of perpendicular from origin is p, which implies that p equals to, by using the concept of distance from point to line, which is b minus b into 0 plus a into 0 minus ab upon a square plus b square, or p equals to ab upon root of a square plus b square. Now squaring p square equals to a square b square upon a square plus b square by cross multiplication, and by dividing p square, a square and b square on both sides, we get p square a square upon p square a square b square, and this one. Cancelling the common terms or identical terms, we get 1 upon b square plus 1 upon a square equals to 1 upon p square. Now addition is commutative, which implies that 1 upon p square equals to 1 upon a square plus 1 upon b square. Hence in this way we proved that 1 upon p square is 1 upon a square plus 1 upon b square if perpendicular from origin is of length p on the intercept form on this line whose intercepts are a and b on x and y respectively. So in this way we complete this very chapter. Inshallah in tomorrow's video lecture we will start new chapter, that is conic sections. If you have problems in this regard, you can text me that very problem or you can call me. So thank you.